So today we're doing a couple of things, still the same section. So yesterday we talked about addition or subtraction of trig identities. Okay, and today we're also talking about combining. So we're going to be combining terms. All right. So first of all, if I take a look at example 1. Example 1 is yesterday's stuff. It really is. And how do I know that? Okay. Well, if I take a look at what we did in our reading today, I've got a sine of theta plus cosine of, but it's different, isn't it? See, it's not sine. It's sine of theta plus phi. Okay. It's not this one. It's not this one at all. Number 1. But number 1 is really going to be that one there. Okay. So you got to look at our notes carefully and say, okay, which formula we're going to use, and it matches up perfectly to that one. So what I'm going to do before I do anything is I'm going to write that down. So I know that sine of theta plus phi is equal to sine theta cosine phi plus cosine theta sine phi. Okay? I've got to use that one. Okay? So let's figure out what's going on. So in this case, I don't know phi. I don't know theta, but I know anytime I see quadrants, I usually build a triangle, right? Anytime I see quadrant 2, quadrant 3, I'm thinking, okay, I see quadrants, let's build a triangle. So first of all, let's build a triangle over here on the side in quadrant 2. So I'm going to put a right triangle in here, okay? So what I'm doing is I'm going to try and build this triangle here. Okay, in quadrant 2, okay? I'm just going to do that. Now, how do I build the triangle? Well, its angle is theta, right? Its angle is theta, sine of theta. So I'm going to build a triangle in quadrant 2. Its angle is theta, so I'll put a theta there in the triangle. And sine is opposite over hypotenuse, so I'm just going to put my 12 and my 13 there, right? Yeah. Did I put the wrong one down? I'm doing this one. Sine, cosine, cosine, sine, sine, cosine, cosine, sine. No, stop me if I make a mistake, Sarah, but do you see what I've got? Yeah. It is plus, and so it's sine, cosine. But stop me anytime. There's so many formulas, you agree? Yeah. So easy to make a mistake. So if I make a mistake, please let me know, okay? Okay, so by Pythagorean's theorem, do you believe me that this is 5? By Pythagorean's theorem, and I can show it, right? I can go, my a squared plus my 12 squared equals my 13 squared, and it's going to turn out to be 5. But actually, it's going to be negative 5. Okay, why it's negative? Totally right, okay? So when I build my triangle, let's get all of the different sides, because when I use my formula, I'm going to need the adjacent side anyway, right? So then let's build the other triangle. So the other triangle is this one in quadrant 3, right? So, yeah.
13 isn't negative.
No, because the radius is always a length, so it's always positive. Really good question. You ask these great questions. You do. See, now that you're up front and you're listening, all right? Because, we've mentioned this before, but you weren't listening, but that's okay. Now you're asking great questions.
Good questions.
It's a great question. So now, let's build this triangle. So I'll build this one up here, quadrant 3, right? And then this angle's phi, right? That's its angle. And we know tangent's going to be opposite over adjacent. How am I doing? Opposite over adjacent, right? But same thing, Eli, you're right, negative, negative, right? Because you're going to go back and down, right? The radius is 5, and again, if you don't believe me, it's a 3, 4, 5 triangle, or you can just use your Pythagorean theorem, right? 3 squared plus 4 squared equals c squared, but that's going to be 5. You guys know how to do Pythagorean theorem, but it really is 5. So to save time and paper, I don't need to do the Pythagorean theorem, right? Okay, now, all we're going to do to finish this problem up is we're going to put these in. It's actually pretty easy. This problem's not bad. So, what is the answer going to be? Well, sine of theta. So, if sine of theta, let's go over to, first of all, theta. Here's my theta, right? My sine is 12 over 13. You agree? Sine is opposite of hypotenuse. So, the answer is just 12 over 13, right? Cosine of phi. So, let's go over to my phi triangle. So, I go to my phi triangle, and cosine is adjacent over hypotenuse. right, for my adjacent over hypotenuse, which is negative 4/5. How am I doing?
Oh, yeah.
So into my phi triangle,
Yeah,
right?
so that's
Which is that.
pretty much.
Okay, plus, okay, cosine theta. So let's go over to my, see how I'm doing it? Let's go to my theta triangle. So I'm at my theta triangle, and the cosine is adjacent over hypotenuse, so it's going to be a negative 5/13, right? And then I'm going to go to sine of phi, so go to my phi triangle, which is here, and sine is going to be opposite over hypotenuse, which is negative 3/5, okay? How am I doing? How am I doing? Okay so far? Yeah, again, this one's not super hard. There's one on here that we will do that's going to be hard, but we'll get to that when we get to it, okay? So, I'm just going to simplify it. Negative 48/65 plus 15/65. So I'm just multiplying fractions, right? That's all. They already have a common denominator, right? And that's 65. And what's negative 14 plus 15? What is that? 33. I think it's a negative 33. So that is your answer. So when and where are you ever going to use this? Probably nowhere. I'll just put it on tape. Probably nowhere. You will need to know these identities in calculus, okay? And if you have to take calculus, you may as well see them here first, right? Other than that, you'll never ever do this. So, but we're going to do it because if you take calculus, you're going to need to know it, okay? All right. Example 2. We're going to do later. We're going to do that because this is the hard one. So let's turn the page and do example 3 first, okay? Now, example 3 kind of looks like the notes we took today, doesn't it? Okay. Example 3 looks like, let's see where we find my formulas. Looks like this one, right? Looks just like this one, right? We've got a sine of theta plus b cosine of theta, but we have instead 3 sine of x plus 4 cosine of x. Okay, so the same thing. And we want to put it in this form, k sine of x plus phi, okay, which is what we have right here. So we're going to use this form. So how do we do this, okay? So first of all, what we need to do is find k. So first, let's find k. All right, how do you find k? Well, I look at my notes. To find k, it's the square root of a squared plus b squared, right? So let's find k, which is going to be the square root of a is 3. Okay, there's a. B is 4. 3 squared plus 4 squared, which is square root of 25, which is 5. Degree? Okay, you get 9. 9 plus 16 is 25, plus it's a 3, 4, 5 triangle again. I try and use easy numbers, right? I don't really like ugly square root numbers, so we'll try and use good numbers. Okay, that's k. So the next thing we have to do is find second. We got to find phi. Now phi is an angle. Phi is an actual angle. We need to find the actual degree measure of phi, or the radian. So how do we find phi? We got two choices. We have two choices. We can either use the cosine or the sine. It does not matter. They're both going to give me the same answer. It does not matter. Lauren, which one do you like, the cosine or sine? It doesn't matter. Let's use cosine then. All right. So I'm going to write down a little cosine formula. So to find phi, it's going to be cosine of phi is equal to a over the square root of a squared plus b squared, right? All right. So let's see what we got. A is 3, right? So this is going to be cosine of phi is equal to 3. And we already did this, didn't we? Didn't we already do this? We already did the a squared plus b squared. We just did that. That's 5, right? Okay, but I still don't know phi. But remember, when I need to find the angle, which button do I push? Inverse. So let's just do my cosine inverse of 3 over 5. And that's going to give me what phi is. Hopefully I'm in degree mode. Okay, mode. I'm in degree mode. Good. Quit. So I'm just going to go cos inverse of 3 divided by 5. And I get an answer about 53.13 degrees. 53.13 degrees. Okay, now it's going to get easy. Seriously. This is not a hard problem, okay? How's it going to get easy? Well, this is the form we need in. So we need it in this. So let me write that down. So here's what we need. Our answer is going to look like this. So the answer is going to be our k sine of x plus phi. Okay, now x is a variable, okay? X is just an angle, okay? We already know what k is. K is 5, right? So my answer is going to be 5 sine of x plus phi. I know phi is 53.13 degrees, okay? Now let me circle and talk about it. All right, real quick. Just make a really quick little comment. Okay, see this 3 sine of x plus 4 cosine of x? It can be rewritten. This is the exact same thing. It can be rewritten just in terms of sine, okay, which would make it easier to deal with, to make it easier to graph if you have it just in terms of sines. Does that make sense? So we took something that was in sines and cosines, we rewrote it. It's the exact same equation, it's the exact same graph, but it's just simpler, okay? It's just one term, okay? All right, now, let's do the hard one. In fact, let's do example 4 is example 2, but I put it over here so we have more room, okay? All right, you ready for the hard one? In terms of x and y. All right, so what I'm going to do is this. Since I've got an inverse, this is an angle. I've got an inverse, this is an angle, okay? So let's go ahead and draw 2 triangles. So I'm going to draw 2 triangles. I'm going to draw a triangle. Draw another triangle. How am I doing? Let's call this one theta and this one phi. I've got 2 triangles. One's in terms of x and one's in terms of cosine, so they would have different angles, right? We don't know what the 2 angles are, but they would have different angles, theta and phi. You getting the whole idea about phi now? So let's see. What do I know about cosine? Well, cosine is adjacent over hypotenuse, right? But right here for x, I need a fraction adjacent over hypotenuse. So that's easy, right? How about 1? So my adjacent is 1 and my hypotenuse is x. Tangent of y, well, tangent, I know tangent is opposite over adjacent. I need a fraction here, so how about y over 1, right? This is truly a calculus type problem. You will do this in calculus, but then you have to do more with it. So in calculus, you have to do this just to set up the problem. Will?
If it's adjacent over hypotenuse, wouldn't it be x
Oh.
over hypotenuse?
Yes. Will, I don't know where my brain is. There we go. Thank you. Yes. Thanks, Will. How about this one? This one's going to be tangents opposite over adjacent. How's that, Will? Better? Thanks for catching that mistake. Everybody see my mistake? Had it in the wrong place. Okay, now, what we have is sine of something plus something. Sine of something plus something. I need a formula, don't I? Sine of something plus something. These are angles, right? This is really sine of theta plus phi. Okay, well, so what this really is really, now this is an angle. This is really sine of theta plus phi. Because the inverse gives me an angle, right? The inverse gives me an angle. The angle I'm using is theta. The inverse gives me an angle. The angle I'm using for this one is phi. So sine of theta plus phi. Let's see. That's in my notes somewhere. That's from yesterday's notes, right? So sine of theta plus phi. I'm going to use this one, okay? I'm going to use this one. So let me write that out. So I'm going to go sine of theta plus phi. And according to my notes, that's going to be sine cosine. Sine of theta, cosine of phi, plus cosine theta sine phi. Okay? Sarah, how am I doing? Catch me if I'm using the formula wrong, okay? All right, now, what am I going to do? Well, this is what I do know, that sine of theta is opposite over hypotenuse, right? Okay, sine of theta is opposite over hypotenuse. So, hold on. What did we do over here? We already had the fractions, didn't we? Right? We just did sine is opposite over hypotenuse. But we don't have nice numbers like this one. What we have is stinking x's. How did we find this other side right here? We did Pythagorean's theorem, didn't we? Right? So how are we going to find this side right here? Pythagorean's theorem. So let's call it A, and we'll go x squared plus a squared equals 1 squared, okay? So if I want to solve for a, I'm going to have a squared is equal to 1 minus x squared. Okay, hold on. What did I do? Pythagorean's theorem. X squared plus a squared equals 1 squared. 1 squared is 1, right? So I brought the x over. All I did is just brought the x over. Okay, so I'm going to solve, brought the x over. Okay, right? So then I'm going to take the square root of that, and a is going to equal the square root of 1 minus x squared. Don't square root those, okay? You have to be able to subtract them before you can square root them. Don't subtract them. You have to square. So that's this side. This side is really a square root of a 1 minus x squared, okay? All right, let's look at the other triangle. All right, let's look at the other triangle, okay? So this is my yellow triangle. Here's my yellow triangle. Put that up there, my yellow one. Let's look at the other triangle. See, the other triangle, same thing. Okay, I need to find this side because if I'm going to do cosine or sine of it, I've got to find its hypotenuse, right? What I did in these notes, I just used Pythagoras theorem to get the hypotenuse, didn't I? Right? So I just a squared plus b squared, I got the 5. But the only problem on this one is that I don't have numbers, I have letters. Well, so what? Let's do Pythagoras theorem again. So on the red triangle, do it down here so you can see it. I'm going to go, all right, 1 squared plus y squared equals c squared. You okay with that, right? Pythagoras theorem. So I have a y squared equals a c squared minus 1. Oh, no. Come on. Come on. That's easy because I'm just going to square root that. 1 plus y squared equals c. There we go. Got ahead of myself. All right, I'm just going to square root it. Just square root. That shouldn't be there. Solve for c, just square root it. So this side is the square root of 1 plus. Yeah, but what is 1 squared? It's all good. You ask the best questions, don't you? You do ask good questions. You know what I love about it is that, you know, sometimes there's other kids that are thinking, what? And then you ask the question, and other kids are like, man, I'm glad Eli asked that question because I didn't want to ask that question. No, I'm glad you asked these questions. Okay? So now, let's finish this thing up. So here's, real quick, our answer. Before I give you the answer, before we do it, let's look right here. What's the question? In terms of x and y, right? The question is write this in terms of x and y. So let's take a look and do it. So how do you do it? Sine of theta. Go to theta. Sine of theta. Go to theta. Sine is opposite over hypotenuse, isn't it? So this is going to be the square root of 1 minus x squared over 1. I don't need the 1, but, you know, opposite of hypotenuse, okay? Times cosine of phi. So let's go to my phi triangle. My phi triangle, cosine's adjacent over hypotenuse, so it's going to be times 1 over the square root of 1 plus y squared. Okay? Told you this is a hard one, right? Well, it's cosine of theta. Okay, let's go find theta. Theta's there. There's my theta triangle, right? Cosine's adjacent over hypotenuse, so this one's going to be x over 1 times sine of phi. So let's find phi. Phi is here. And phi is going to be opposite of hypotenuse, which is going to be my y over my square root of 1 plus y squared. Okay, how am I doing? It's hard, isn't it? Sorry, Stefan. You're like, right? That's fine. I'll just watch it. Okay. Yeah. So now, that is the answer, but I'm going to tidy it up. Okay, you guys mind if I tidy it up a little bit? So if I tidy it up, I'm going to go square root of 1 minus x squared over the square root of 1 plus y squared. Okay. See what I did? Just multiplied by 1, right? I don't need the 1s. Plus xy over the square root of 1 plus y squared. Okay, how am I doing? This is a decent calculus problem. No, we're not in calculus, but calculus is going to do something with this. We won't. We're just going to get the answer. Then in calculus, you do something with this, okay? I can do one more thing only because I noticed that they have a common denominator. Are you okay with that? I can do one more thing. I mean, I suppose if you didn't do it, it wouldn't be the worst thing. But I do see right off the bat that, wait a minute, they have a common denominator. So let's rewrite it with the common denominator, right? And then on top, or in the numerator, let's have the square root of a 1 minus x squared plus xy. Okay? And that would probably be as far as I'm going to go. Now that's one really ugly answer. Okay? So if you never take calculus, don't worry about it. You'll never need to do this. If you take Calc 1 or Calc 2, you're going to find this problem somewhere in there, okay?